In this question, you are given the parametric equations of the curve C. So when you are given parametric equation, the x expression here refers to the x coordinate. Okay, so this gives the general x coordinate of a point on a curve. This gives the y coordinate of the point on the curve. So this is a concept that you need to know before you even do this question. So let's do part one. So part one is quite easy. Just find dy dx. All right. So just show that dy dx cotangent theta. So we're going to start with finding dx d theta. So we're going to differentiate x with respect to theta first. So this will be a 2. So this is sine 2 theta. So you can see this as f theta. So differentiating sine f theta would be cosine f theta. So we copy the f theta, which is 2 theta. Then we need to use chain rule. So differentiate f theta. In this case, 2 theta will be 2. Then for y, we will write it. I'm going to write this as a bracket square, so it's easier for you to see what method do we use to differentiate. Okay, so again, we're going to use chain rule. So I will first bring down the 2, so that will be a 4. Then copy sine theta, so that's power 1. Then using chain rule, you need to differentiate sine theta. Okay, so differentiate sine theta is cosine theta. So now we are ready to find dy dx. So dy dx is dy d theta over dx d theta. So you write down this formula first. So we have 4 sine theta cos theta over 2 minus 2 cos 2 theta. So at this point in time, you may want to look at what result are we expecting to get. This is a show question. So we know that we need to further simplify to get cotangent theta. So one thing you may want to observe is that the final answer is in terms of theta, but right now we have 2 theta over here. So we're going to use double angle to convert cosine 2 theta to in terms of theta. So we're going to keep the numerator. And convert cosine 2 theta to in terms of theta. So how do we do that? Go to MF26 with double angle formula. So MF26, the double angle formula for cosine 2 theta, there are 3 available. So in this case, we will use one of the first 2. So you may want to think about, so you can use either one, all right? But of course, if you use one of these, it will be a shorter method. So I'm going to use this. The reason is because if I were to use this, I can cancel the 2. Okay, so let me show you what I mean by that. So I have 1 minus 2 sine 2 theta at sine squared theta. So you see that the 2 is being cancelled. 2 minus 2, right? When you expand, you get 2. So 2 minus 2 is being cancelled. Then this one will be a 4. So immediately you get 4 sine squared theta. All right. But for those who use the first one, you can also convert it, just that you might need one more step, okay, to get to this. So alternatively, some of y'all might factor out the 2. This is another way, factor out the 2. And you should be able to see that this one, you can actually also use this formula here, because cosine 1 minus cosine 2 theta is 2 sine squared theta. So you just replace this with 2 sine squared theta. That will do as well. Okay. Okay, so now we're going to cancel like terms. So we are left with cosine theta over sine theta, which gives us cotangent theta. Now, because this is a show question, so I'm not going to skip steps. So let me just very clearly show that this is cosine theta over sine theta, which gives cotangent theta. So this is a show question. So whenever you have questions that require you to show an expression or show a result, please ensure that you give very, very detailed working. Do not skip any step.